Hey guys, I've spent a stupidly long time perfecting, drumroll please, a button library. Not because I'm sadistic, but because this will make your life, and of course my own, much easier. Welcome to more Little Man Builds. Today we're expanding on our RTOS template and adding a push button. Now this might sound simple, but I can promise you we'll be making this library pretty abstract. We're ultimately designing for the Power Wheels electric vehicle. Please check out our project here. So we need a scalable solution where we can differentiate between a short and a long press, having multiple instances for debounce settings, or we might eventually run out of physical pins on our ESP32. So this library needs to work with a port expander, such as an MCP23017. So whether you're a beginner or more advanced, I'm pretty confident you will learn something today. By the way, if you're liking this content, feel free to smash the like button or consider subscribing. It helps the algorithm and I would love you to join our community. Let's crack on. So just a quick design tip. Normally with a breadboard, when you put the ESP development module in, you can only access one side of the pins because it's simply too wide for the board. So a simple solution for this is to grab a knife and cut down one side of the breadboard just where the power rails are. And what you can do is this simply detaches, and then you can grab a separate breadboard like this, and you can put the two together. Now, when you put your ESP32 in the middle, you have access to both sides of the pin. Simple solution. Hope this helps. We're going to start by adding 3 new folders. The first one is HAL, which stands for Hardware Abstraction Layer. The second one is lib or library. Oops. And the third one is utilities or utils. So we can save this. And then we can go into our app config file. Now, this is what we achieved last time, but we're going to make a few amendments. So we'll make this test short and we'll add another one called loop interval test long, and that will set to 1000 milliseconds. And today we need to assign some buttons and indexes. So we'll create a button pin assignments /index section. X, which is test button with a GPI or pin number of 7. Now I could add more buttons by just simply saying new button, and that could be put on GPI number 6, but for today we do not need this. Now next is to create a button pins struct. And what this will do is to generate members for each button name and pin, so we can reference everything more simply. And this is effectively the same as writing something like this. Constant expression uint 8-t button test is equal to 7. And this builds a C++ array of the button pin numbers in the order listed. Next, we want to calculate the size. So this is effectively calculating the number of buttons at compile time and then dividing by the array size, which is one element, and that will give us the number of buttons. And then an enumerator finally. And this creates an enumerator for each button, allowing you to reference each button by name rather than by number. So this is quite a useful pattern, which we'll make use of in the following code examples. So next we actually need to create the button library. So we'll jump over here and we'll go new folder and we'll call this button handler. And we're going to add a new file underneath here called buttonhandler.h. So you may notice that everything's now green, and this means that a new file has been added. So I've got Git running now in the background, and this means that everything that I'm writing here today you can access for for free on the GitHub page of Little Man Builds. So what we're going to do is we're going to put in our header. So we want to create a generic class. And so it's a multi-button handler, which takes a parameter n, which will act as the number of buttons that are existing at compile time. So to do this, we're going to put in a template, which is size t of n. And this sets the number of buttons at compile time. Now we're going to create a class called button handler. And at the front of our class, we're going to do a static assert. Just make sure that n can't be 0. And this ensures there is at least one button. Great. So in each class, you have public member variables and you have private member variables, which will allow us to debounce and change the press duration for each set of buttons. So the main thing today is we want to make this an abstract class. So we're going to add another file in HAL, which is the abstract class, which is prefixed with an I, buttonhandler.h. Now, there's a number of reasons for this. It gives us hardware independence, which is the main reason for doing this, because we might run out of GPIO pins. So when we switch from a GPIO pin to using an MCP23017, for instance, we just swap the implementation with no code changes. There's a couple of other benefits, including code reuse and extensibility, but in short, this is just simply a contract for functionality. The implementation is hardware or platform specific, and the logic works with either the present implementation or future implementations as well. We want to also now include iButtonHandler. And in iButtonHandler, and I referenced these earlier, but we're going to say that we need for type of button press event. We can have long, which is a long press event. So here we said, say this is a configuration for button debounce and press duration timings. And this is the minimum time for a long press. Now we will also want to be able to update these on the fly. So we want to use an initializer list. Okay, so we need to also put in our abstract class. And that's about it for now. We'll put this one over here. All right, going back to our button handler now. So the first function we're going to drop in is the read function. So we're going to say using a read function. And so it will take the button index and return true if pressed. Now next, we're going to construct the button handler object. So button handler. So internally within the ESP32, there's pull-up resistors. This will bring the value of the pin up to the 3.3 volt working voltage. And so when the button is pressed, to prove this, we can bring in a voltmeter. And on one side, I can also connect to GPIO 7. And on the other side, I can connect to ground. So we should see positive voltage. There we go, just above 3 volts. And as soon as I press the button, it goes to ground, so 0 volts. And when it's released again, it goes back to the internal pull-up voltage of just over 3 volts. That's how we know there's a button press event. So we also need to initialize our last state, and it's going to return, read the pin for a button press. Now the next function we need to do is we want to scan and process button states. So the debounce is looking for some type of stable state. When you press the button, there's obviously some type of millisecond gap in between the time when it's 0 and 1. And we want to avoid the software wondering what state it's in. So we're just going to wait for a stable state change. And then after that, we know we have a press event. So for this particular time, we're going to say void update. And this is going to check to see if a button is pressed. Now we need to add the debounce logic. We'll only accept state change if stable for the debounce milliseconds. So we're going to say if pressed, and the else here is if button is held, keep press start I. So basically saying do not reset. Now the next function we're going to add is to check if the button has been pressed for that particular button ID. And then we put in another and final method, which looks at the button press type event. So you want to get the press type, and then we return the event that we stored earlier. So there's our button handler library almost finished, but I won't type them all out because it's too slow. But in this particular case, I do a large copy paste. We just create a virtual method of each. In this case, we have a destructor, but for the 3 methods that we wrote, this is the update abstract method, the isPressed abstract method, and the get press type abstract method. So now we need to go back into our Main.cpp and update this accordingly. Now it's generating an error because we changed the variable name here earlier. So we'll just say call this long. Now I don't want the handler task to show me any debug output, so we will comment that out. And for this one, we want to change the duration and we will test on this short interval. So the first thing we have to now do is include the button handler library. And underneath here, going to add some task context structs. So this makes it work within our RTOS structure. So we're going to create a struct called listener context. Now in the setup, we're going to change this portion because we need to declare our hardware objects. And then we will also create these task context structs. And so we'll create a static listener context. Now, in the last video, we talked about being able to pass variables to our RTOS tasks. So now that we've got the context, we can say we can pass listener context to our RTOS task. So now we can go down to our listener task. All right, there we go. Please accept my apologies as there were a number of typos and braces, variable names, capitalized, etc. that were wrong. I have fixed this in the GitHub file, but basically you can go back through and some examples with these button IDs where I just wrote them incorrectly. So again, apologies. So apart from all the other errors that I actually put in, my biggest one was forgetting to update. And in the for loop, we actually need to call the context buttons update. So now when we upload it to the ESP32, let's see if this works. All right, so let's give this a test now. So when I go over to here, I can press the button and you can see button is pressed. And when I release the button, it says no input detected. So this is working perfectly. There's a slight delay on the camera, so apologies for that, but it is clearly working, which is great. So that was the first implementation of the button library. Now we want to also show you how we can do the button press type events. So we can say button press type event is equal to context. I can say debug line, no input detected. So let's bring in the camera again. And we'll try firstly with a short press. And then we see a long press. Another short press and another long press. So it works just fine. Now, lastly, we had an implementation where we can change the length of the pauses by, instead of using the default rate, we can make our own. So for this to happen, we can create another instance of button handler. So here, I could create something called button timing config. We could call it slow timing. And we could say that the debounce is 50 milliseconds, the slow press is 300, and a long press is 2 seconds long. Now, in this case, we can say static button handler. Now, everything else should be the same. So we can upload this to the ESP32. And let's bring in the camera again. And we test it this time. So a short press is slightly longer. So there's no noticeable impact. And then when I hold it for 300 milliseconds, we get a short press detection. And then I have to hold it for over 2 seconds for a long press to be detected. So our configuration works. Hope you guys learned something today. Thanks for watching.